Hello, my name is Ben Delvin, and this is my final project submission for Intro to Computer Systems, in which I have created a small game that I call Dungeon Master, which fulfills all the requirements of client-server connectivity and multi-threading within the server. I created it in Python. Here's all the required files to run it. The game data necessary for the server to interpret and save to and load from is all saved within comma-separated value files. I'll start just by demoing the project, and then I will discuss the implementation of the client and the server. First, you run the server simply like this. The server's running if you get no feedback there because you're starting in the loop. And then you run the client, and you have to spell client correctly. And first, it will display the name and ask for a player name for your player. So you can enter anything. My name is Benjamin Delvin. My full name, Benjamin Joseph Delvin. Very fancy. All right, so now we can see that the server has confirmed connectivity with the client. So welcome to Dungeon Master. You are trapped in a dungeon with no way out. You can read Game by Ben Delvin. At each stage of the game, it will present three options. You can proceed, check the status of your character, or save and exit. So the status checking takes us nowhere, so I'll go ahead and do that first. It shows the player name, the room we've got to so far, our attack stat, maximum health points, speed, the number of potions we're carrying, and our armor and weapon, the name of our armor and weapon. The save and exit saves and exits. So if I press 3 and enter, it will close the client. And you see this, the server says that it has received the instruction 3. So we can go ahead and open the player data and see that Tester Ted, Raggy Ron, Dave Dud, Great Goblin, and Benjamin Joseph Delvin are all indeed saved here. These are just some test player names I was working with. So we can start the client again, Python client.py, and we should see once I put in my name that it connects to the client again. It receives instruction 1, and this time it does not give us the intro because it has actually loaded the player data that we already saved last time. So it doesn't need to give us the whole intro all over again because it knows we've already seen that. So the next thing I can do in the main focus of the game is I can proceed, and I enter room 0 and encounter a mosquito. So then I get the choice to attack, defend, or use a potion. And you can see here the server received instruction 2 and generated a mosquito room. So what has just happened is the server has just generated an entire an enemy from a set list of enemies, and it has also sent data for possible rewards that the player can receive after they've beat the enemy. So here I'll attack the mosquito, and it was a successful hit. I did 3 damage. The mosquito was defeated. The mosquito is very weak. And I find a potion. So here I can inspect the potion. It is a potion which restores health, and I can take the potion or ignore it. I will take the potion. And then I can check my status again now that I'm at a rest state, and I can see that I do indeed have 1 potion. So if I proceed again, I enter room 1, moving up from room 0, and the server receives instruction 2, generates a roach room, and I have encountered the roach. I can attack the defender, use my potion. So I'll attack. And you may notice that these messages for the player's actions and the enemy's actions, they take a moment to appear. That's because within the client, there's a multi-threading system based on the player and the enemy's speed stat, which makes the whoever's faster moves first. And with subsequent turns, if you are much faster, you may even move twice for every time the enemy attacks once, or vice versa. So the roach took 1 damage, I took 1 damage. So I'll just play this through here. 2 damage, 2 damage. The roach took 1 damage. See here, I'm so much faster than the roach that I got 2 turns for its 1 turn. And that just builds up over time. So keep fighting, miss. Okay, so the roach was defeated, and I find rags. I can inspect the rags. These rags are an armor item. They increase my HP by 4, and they set my speed multiplier to 1.7. Speed is calculated by your weapons speed stat as a base, and then your armor's speed multiplier on top of that, multiplied by that. So I will equip these rags, and I found something else. There is a possibility of finding 2 items, and I found a stick, which is a weapon, which gives me 2 attack as opposed to the 1 with my bare hand, and decreases my speed a little bit to 15. So I'll go ahead and equip that, and then I can check my status. I made it to room 2. I have 2 attack because of the stick. My max HP is 24 because of the rags. My HP is 17. My speed is 25.5 after the calculation, which is slightly faster than most of the enemies in the game. And I have 1 potion. My armor's rags, and my weapon is a stick. And as you can probably tell, the armor and weapons in the early game are not very glamorous, but as you continue forth, you get more interesting equipment. So proceed, and I will just fight here until I find some rags, which I'll ignore, and I'll save and exit the game. In which case my save data will be entered in. So the implementation of both the client and the server. Here we can see the client, Dungeon Master version 1.0. Here are our constants, which are necessary for as you can imagine, certain things hosted in the port. The class declarations, the character and the enemies are held within these weapons, armor, classes, server functions. This is called to load player data, and if it fails, it will return 0, which tells the game to start a new character. And this generates the room, or it calls the server to generate the room. At least I can show in the server script it actually doing it. And here it calls the server to save the player data. And it does this simply by sending a instruction and to the server, and then afterwards the server will wait for a player data in this case. And it works similarly to one, whatever it may be. The client functions are much more complex in the client script. It's the new game function which simply prints a message that we've seen. The player action, the player can attack, defend, use potion. The player battle, this just calls the player to actually do those things. Enemy attack, this is the enemy's attack script. They can miss, the player can defend against them, they can hit. If their health is below 0 and this function is called, then it will print that the enemy collapsed instead of any of their actions being taken. And here's the previously mentioned threading functions. Here's all the global variables necessary. Player defending the second reward in case you get a second reward. This is the main condition for the main game loop, and so on. This is just for the input of any type for use. Yes. And here's the 2 threads, which are declared early, and the thread events necessary, and the player and the enemy's default, which is overridden pretty much immediately. So the game starts, this is the game code, prints the title, enters the player name, then it creates the socket and connects to the server. Calls the server to load the player data. If it cannot, it starts a new game simply by printing that message. The main game loop while the game is running, it will loop this over and over and over. So out of battle, you get these options, and you can use these to call server functions or check your status, which just calls the player display, which is a class function for the character class. In battle, so you're in a loop inside of a loop here, that if the battle is equal true, we go through, we start these threads, start them here, and these threads are up here, they count down, or they count up to a certain tick threshold, and then it lets the player act, the player's action, and so forth, as we've been through. But these loops, the battle loop, also checks if the player is defeated, or if the enemy is defeated. If the enemy is defeated, we go into the reward menu loop, and there you can get a reward, and possibly a second reward based on the second reward chance here. So that's the client script. The server, we have the constants necessary, the same classes, character, weapon, armor. We have the load player data, in which it reads the CSV every time this function is called, and if the character name matches the input sent from the client, then we send it back. Otherwise, we don't, and the client makes a new game. So here we generate the room data. This is done through choosing a random enemy. Get random from a list. This is a different function I made because this is done over and over for the weapons, armor, and the enemy. It just grabs with a grab index, which may go up and down based on our range, which is the constants at the top, and generates a room. The character has plenty of attributes, way more than necessary for the enemy, so I just put the data for the weapon and the armor that could potentially drop from them into the other attributes that are unused, because the enemy only has name, health, attack, and speed. That's all that's necessary. And then here we can save the player data, but just by simply appending it to the end and interpreting the JSON that is sent from the client. Here we have the global variables. Here this is another server function, but this is the main loop for the threads that are necessary for, to satisfy the requirements of the project. Where's the thread start? Yeah, down here. The server has a listing queue of 8. It's just arbitrary, really. And then after it accepts, it prints that it's connected to the client, and it starts a new thread, passing that client. And then here, that client, through its connection, can pass instructions, 1 byte instructions, in which case it will print that it's received the instruction and then complete the corresponding function. And then here below that, which runs before anything, it reads the enemy's file, the weapons file, and the armor file, which you would have to close the server to update because it only reads it once. It has no reason to read it so many times. And then it will create a socket and bind the IP import, start listening for the client, and the client can connect. So yes, and the server is still running here. The client is not. I'll go ahead and clear this. No, I will actually clear it, and then I'll start a new terminal just to demonstrate that the server can host 2 clients at the same time. So Python client.py test1. So it's connected here. Python client.py test2, and now it's connected here. So we can do 2 things at once here, and the server will respond to everything. Okay. So here we generated the roach room, and the mosquitoes and the roaches are common enemies. But here you can see it's not the exact same thing. It is random, truly, as you can tell, because this client got a roach room, this client got a mud room, which the mud is a much more dangerous enemy for early game. We'll discuss some of the challenges that I faced. The client-server connectivity was a big challenge. I had to teach myself how to do that through Python. That was kind of one of the hardest parts of this class for me. So, and I have no experience with that, whereas I have experience with game development in general before this class started. So that was pretty difficult to get those working. The threading, which is much easier by comparison. I gave myself a day for each. I developed this in about 4 days. The challenge that I currently have is I would like to implement overwriting if it's the same name, because you can only save once per name currently, because it'll grab the first name. So since I've already saved on room 0, it will never grab this room 3 save. For Benjamin Joseph Delvin, balancing the interactions between the player and the enemies with the dagger is a very good weapon. That was quite difficult, and that is about everything. Thanks so much for watching.